Okay, so welcome again, everyone. So I'm very happy to introduce today to Italian philosophers of science, friend of mine too. Claudio was one of my supervisors. So today they're going to speak about coherentism, in particular about the quantum case. So they have a couple of papers about that. I'm sure they're going to give references. So as far as I understand, this is an ongoing project. So they did something very nice. Namely, they on purpose decided to develop a new part of this project for this seminar. So I'm very happy about this. Thank you, guys. So yeah, whenever you want, you can go.
Hey, thank you very much. I will start. So let us start by thanking you, Christian, for setting this up. It's great to be here. And yes, it's great to be here and try to share some results and some ongoing work that we've been actually working on for quite a while now. So we are really anxious to actually have feedback from you guys. So basically the idea is that, yes, okay. We will first give you a general outline of what we mean by coherentism at a very general metaphysical level. So I will first introduce very quickly the issue of fundamentality and foundationalism and its alternatives. So coherentism is first of all an alternative to the traditional metaphysical view of reality, according to which we have a sort of hierarchical structure with an ultimate basis, something ungrounded that does all the work of grounding all the rest. So this is exactly what we want to question, at least. So given this very general picture, then we will zoom into quantum mechanics and in particular quantum entanglement. And we will try to convince you that coherentism is perfect for providing a nice ontological interpretation of quantum entangled system and maybe quantum mechanics in general. In doing so, we will mention structuralism and monism, which are two very popular alternatives to coherentism. Actually, they are the most popular views of entanglement because coherentism is not really on the table yet. But again, we want to convince you that this is a novel approach that is worth taking seriously. And it's actually, we think, preferable with respect to structuralism and monism for many reasons. So we will try to mention some of these reasons. And time permitting, Claudio will also say something more about possible ramifications, applications, and prospects for the research. Okay, so this is the plan. Starting from the very general metaphysical issue, some terminology first. So metaphysical structure. By metaphysical structure, we simply mean the fundamental architecture of reality, the way in which things in their generality are organized, structured at a very general level. One important thing is that when we say fundamental architecture, we don't mean that there has to be something fundamental. So these two are two separate notions. The fundamental ways in which the universe is may not include fundamental items. So this is our basic starting point. Now, on the other hand, there is this traditional view in metaphysics, which is foundationalism, which is exactly the view according to which there must be a source of being. There must be a starting point, something ungrounded that is the foundation for everything else. So this is our polemical focus in a way. Just to give you a very broad picture, if you don't already know this, which you probably do, if you want to be a foundationalist, you can be a foundationalist of either of two sorts. You can be a pluralist, which basically means that you believe there are many, at least two fundamental items. And of course, the paradigmatic version of pluralism is atomism. Okay, so in this case, the foundationalist believes that there are many mereological symbols, but foundationalism is not the same as atomism. Okay, so this is just one variety. On the other hand, you could be a monist and believe that there is only one fundamental entity, and this entity is the universe. So this constant U here stands for the universe as a whole. And a monist might be a sort of Parmenidean monist and believe that really there is only one thing, the cosmos as a whole. And this is known as existence monism. Nowadays, most people are actually priority monists. So they believe that the whole is prior, but they actually also believe that there are parts, okay? So this is an important difference because at some point, Claudio will talk about monism with respect to quantum systems. And actually, we're going to talk about priority monism. But this is just to set the stage. Okay, we are not going to discuss foundationalism in any detail. So our main objective today is to convince you that there are alternatives which are really important. We need to take them seriously. So first step, which are these alternatives? Let me show you visually what we are working with. So let's talk about grounding for a moment. I'm just using this term because it's very popular and you probably know what it means more or less. But let me also point out that we don't really need to work with a special notion of grounding. We don't really need grounding at all. We are just using it as a shortcut. So whatever relation or relations you take to actually structure reality at the most fundamental level, then let's call it grounding for simplicity. Actually, later on, we're going to talk about ontological dependence and priority. So for present purposes, just take grounding and ontological priority as synonyms, okay? So we will, many times we would say something like the fact that entity X exists grounds the fact that entity Y has such and such properties. Simply take these as more or less the same as saying entity Y depends on entity X for its having such and such properties, okay? Nothing really hinges on this particular choice. So when we, try to study the structure of reality, we basically start with a general request for a ground. So whatever you have in front of you, it may be a bottle, a chair, or a tree, a quantum entangled system. What you want to know is, how is it that I have this thing in front of me? So you start with a request for a ground, okay? And you have two options. Either grounding relations build up a hierarchy, a sort of pyramid in the vertical direction. You move from the less fundamental to the more fundamental. In that case, you may additionally believe that there is something really basic. And in this case, you have the first option here, which is foundationalism, which I already introduced. But you may also believe that, grounding relations go in a vertical direction, but there is no endpoint. So you keep on finding more and more levels. And in this case, you would be an infinitist. I find this very interesting, but we have no time to discuss this today. So let us move to the third option, which is actually very different because you deny that grounding relations have to go from the less to the more fundamental. Instead, you pose it sort of horizontal, same level grounding relations. So you have many entities and they are symmetrically related one to the other. They support each other. If you are familiar with the debate about justification in epistemology, this is very similar to epistemological coherentism. If you're a coherentist about justification, then you believe that there is a belief set and all the beliefs support each other. So there is no set of beliefs which is more fundamental than the others. You have these interconnections, okay? So this is exactly the view that we want to develop more in the metaphysical case. So let me say something more detailed about this. What does it look like if you try to see it more closely? Just to be a little bit more specific. So traditionally, metaphysical structure is understood in terms of strict partial orders with fundamental basis. So this is mathematical terminology to say basically the same thing that I already said. you believe that, you have these grounding relations, these dependence relations, and they build up a structure. And this structure has very general formal features. If you're a foundationalist, you believe that these features are the following. Whatever relations you are using, it has to be irreflexive, it will be asymmetric, and it is transitive. And on top of this, it is well-founded because you have this ultimate ground. So these four assumptions are enough to characterize foundationalism, okay? Now, if you are an infinitist, you will drop the fourth, okay? Now, coherentism does a different thing. First of all, you will deny well-foundedness because, you have these horizontal connections, so there is nothing more fundamental than anything else. But on top of this, we also want to question assumption number 2. We are assuming that it is the case, or it can be the case, that grounding relations are symmetric. At least some instances of grounding are symmetric. And now a potential problem arises, because you may know that asymmetry follows from irreflexivity and transitivity. So given that we want to deny asymmetry, by modus tollens, we have to give up either irreflexivity or transitivity or both. Now, transitivity seems very intuitive, right? Because if A grounds B and B grounds C, it seems impossible to deny that in some sense A grounds C, okay? We may want to discuss this in the Q&A, but we are taking this for granted. So Claudio and I believe that what we have to do is not an option. We have to accept reflexivity. And now you may already see what the objection, the obvious objection is. The objection is basically that if you have at the basic fundamental level of reality a reflexive relation, then you end up with empty explanations, right? Because you have something like this. Whatever A is, it could be a fact, an entity, a property, you end up saying basically A grounds A. A depends on A. The fact that A is such and such is explained by the fact that A is such and such. So this is probably the reason why coherentism is so ignored in the literature, to say the least. It's not even considered, actually. But Claudio and I also believe that this objection is as strong as misguided, because it's on a very intuitive level. It is very powerful, right? Because reflexivity is bad in explanation. But let us try to convince you that it is not necessarily so bad. So first of all, circularity might be vicious if you have the same thing acting as the explanans and also as the explanandum, as in the previous case. A explains A grounds A. But it could also be a good virtuous circularity. For example, if you have a sort of symmetric relation in the explanans, then this circularity could be genuinely explanatory. And indeed, what we're going to say later is something like this: the symmetric dependence between A and B, where A and B are placeholders. It will be particles or physical systems, whatever. This symmetric dependence accounts for something else. So we will have to fill the dots, and this will come later. But basically, the first reply is that the circularity is not vicious if we distinguish between the connection between the explanans and the explanandum and what goes on in the explanans, okay? Now, a second related reply is more general. It is not obvious, at least not to us, that reflexive relations cannot be the basis for genuine explanations. It is not always the case that whenever you have reflexivity in explanatory relations, then you have bad explanations. So to convince you of this, let me go back once again to the debate about justification in epistemology. Okay, one of the options in epistemology is, as I mentioned, to be a coherentist. So you believe that, the different beliefs that you have in your mind, they support each other. Now, what is important for our present purposes is to distinguish between two ways of being a coherentist about beliefs, first of all, and then parts of physical reality. Okay, on the one hand, you might be, for some weird reason, a naive coherentist. So probably the early formulations of coherentism about justification, they look like this. You have any belief set, suppose a very simple belief set with 3 beliefs, A, B, and C. And the coherentist originally said, well, look, you can start anywhere. A justifies B, B justifies C, C justifies A. And that's it. Everything has an explanation. But this is actually bad, because if you look at it, you end up having to say that A fully justifies A. So all the work of justifying A is done by A itself. And we agree that this is bad. So this is the sort of paradigmatic vicious circularity that we want to avoid. Okay, luckily enough, in the epistemology literature, there are some suggestions. Most coherentists nowadays are sophisticated coherentists, so they don't actually buy into this picture here. They actually say something different. And the story goes something like this. You have a bunch of beliefs. It could be the beliefs of the subject or possibly entertained beliefs, and they do something together. They determine a specific belief structure. So there is something else beyond the beliefs. A belief structure which is simply the complex of all these beliefs taken together. Then this complex may or may not have some properties. It may be coherent, it may be useful for the subject, it may be credible for the community, whatever. The idea is that if S, the belief structure, has these properties, then S in turn lends support to the individual beliefs. Only at that point, the beliefs become justified, okay? Then you may think, how is this different? It is very different, because it seems to us that in this case, what is reflexive is only partial justification. It is only partial because it is impossible for each belief to justify itself. It has to do something together with other beliefs and together with some features of the structure as a whole, okay? And our basic claim is that reflexivity of partial justification is not bad. And of course, now you can imagine how it goes. In a metaphysical case, we want to make a very similar claim. And the claim is, take a bunch of physical entity. Entity here is an umbrella term, whatever you want to discuss. Quantum systems and trees, chairs, whatever. The idea is that the joint existence of these entities determines the existence of a specific whole or plurality S, where S is not identical to just the set of the entities. It is a connected, it is a structured plurality. As before, this plurality may or may not have some properties. If it does, then the nature of S constrains and shapes the features of each particular entity. So again, the idea is that each one of the initial entities partially depends on or is partially grounded in itself and all the other. But only partial dependence is reflexive. Full dependence is not. Same with grounding. Partial grounding is reflexive, and this is good, but it is not bad. Full grounding is not reflexive, which would be bad. So this is basically our answer to the circularity objection. In some cases, you can formulate coherentism in such a way that the circularity is not actually vicious. Let me add one important thing. As you can see, we say whole or plurality here. This is not just a terminological issue. It is very important to stress that the coherentist is not committed to the existence of an additional entity, say the mereological sum of the initial entities. No, we don't have to say that. We only need to say that the starting entity, they do something together. They are structured together in some way. And it seems to us that this does not imply that there is an additional entity. Why is this important? Because it makes a whole difference between coherentism and monism, right? Because if we had to say that the whole is prior to the parts because it determines the properties of the part, then this would be foundationalism, okay? So make sure you get this. If you have questions, please ask. This is very important. So summing up, metaphysical coherentism is the view according to which it is the case, or at least it is possible, that for some entities, each one of them partially depends on or is partially grounded in itself and all the others. By doing this, they constitute, let's call it a connected plurality S, and this determines them in one or more of the following respects. This is another important point. We are not just saying A grounds B and B grounds A. We want to go fine-grained enough to give you interesting explanations, right? And we think ontological dependence can do this. We need to specify in which respects A depends on B and B depends on A. And we think once you do that, you realize that there are many different, very interesting applications, even outside physics. And Claudio will talk about this. So which are these respects? So far, we could think of three main respects. Existence. As a model, you can think of quarks at low energy regimes. They only exist in triplets. Even if it's not a metaphysical necessity, we can talk about this. Second respect, identity. Think about mathematical structuralism. If you're a structuralist, you believe that the identity of numbers is fully determined by all the other numbers, structured in some way. Then there is a third respect, which is the most important for us, because we think this is what happens in the entanglement case. Two things or more things, several things may depend on each other for their qualitative profile, their physical properties, right? And again, you can see there is no necessarily vicious circularity, right? Because you can have two different existences. They exist, and by interacting in some way, they affect each other's qualities. We don't see any viciousness in this. Okay, just one last thing before I leave it to Claudio. One potential objection could be, look, even assuming that coherentism works, what about the case, the limiting case in which the universe only has one thing? Surely in that case, you cannot really distinguish between partial and full dependence. So in that case, you have very bad circularity. And we think this is not really an issue, but it allows us to introduce a potentially useful notion, which is the idea of quasi-reflexivity. A relation is quasi-reflexive if it holds reflexively only provided that it also holds non-reflexively. And we think this is exactly what happens. So coherentism does not apply in the limiting case in which you only have one object. It is genuinely a view about pluralities, okay? So if you want, we can discuss this notion later, but basically the idea is that you have something like this. Entity X partially depends on itself only if X also partially depends on some other Y, which is not numerically identical to X. Okay, so enough for the general characterization of the view. I try to convince you that the circularity objection is not bad, and there are technical ways of getting out of this circularity objection, including this idea of quasi-reflexivity. So that's it for me. And Claudio, do you want to use your PPT or shall I keep it?
I mean, it depends. Maybe if I can share it, it's going to be easier for me. But
you try to share yours.
Yeah.
Okay.
I mean, can I do this, Chris?
Yes.
Can I try? Wait. Okay, let me see. Do you see mine now?
Yep.
Yep.
Okay, play from current slide. Let's see. Okay, good. Okay, good. So Matteo got us through, the general part, right? And hopefully you're convinced that it's not, coherentism is not obviously false. And so now what we're going to do is we're going to focus actually on particular cases and quantum mechanics in particular. And then I'm going to give you some consequences, which is entirely new work. That's why we wanted to actually have new work here. And we know, because there are people that work in these fields, and we'll see where we get. Okay, good. So summing up was minimal coherent. We will take minimal coherentism to be the view that there are interesting cases of symmetric dependence. And wait, okay. So, and as Matteo just said, I mean, this could go against traditional wisdom, that is, dependence induces a well-founded strict partial order, which is metaphysical foundationalism. And also, it's going to be important later on against another view, a traditional view, which is absolute fundamentality, is independence. And this is going to be crucial when we go back. Now, unfortunately, we have to signal that this traditional wisdom is really widespread throughout Western thought. And unfortunately, especially for me, this is encapsulated here by one of my most favorite person in the entire world, which is Dante himself. So Dante here, this is the 28th canto of heaven, right? This is where Beatrice explains the structure of reality to Dante. And as you can see, this is just one amazing canto in which actually Beatrice exactly says that all creation depends on one point. Okay, this is traditional foundationalism at its best, I would say. And but I mean, to rescue Dante a little bit, I'd say that this is actually philosophically very deep. So if you notice, Beatrice doesn't say that God created the universe. She's really saying that the universe depends on God, which is, I think it's a very profound insight by Dante. Now we're going to challenge this, but still, this is just because I have a soft spot for Dante. More poetry is coming later on, so please stay tuned. Okay, good. So as Matteo noticed, right, we think that symmetric relations of dependence can do a lot of work. Now let's see some examples to actually convince you that it shouldn't be a bias. There shouldn't be a bias, foundationalist bias towards well-founded strict partial orders when it comes to the structure of reality. So here are some examples in metaphysics, okay? So bare particulars and property instances, immanent universal and essentialism, trope theories, phenomenal reality and ultimate reality according to Buddhist thought, they all have been modeled using like symmetric notions of dependence. Okay, but so in philosophy of mathematics, there's a famous position which is close to mathematical, to structuralism, which is Linebo, or the Linebo mathematical structuralism. And this is Johanna Wolff actually discussing physical structuralism, the view that then systems, physical objects depend on structures. And in the paper, Matteo and I actually distinguish that from actually coherentism, which it seems to us that Linebo is actually invoking some kind of coherentism here, not structuralism, because it says that every object, okay, depends on every other object, which is exactly what we take to be the signature, let's say, of coherentism. And in philosophy of physics, I don't know whether Vincent is here because I see only 4 of you. So Vincent Lam and Michael Esfeld has used symmetric notions of dependence to provide what they call modern structuralism. This is the view according to which objects and relations mutually depend on each other. And as Matteo just suggested, there's now an interesting to actually account for quantum confinement in terms of symmetric notions of dependence. This would be, I mean, anyone that can provide some physical details here, I think would be a great service, because as of now, there is just basically the thought that the 3 quarks like are symmetrically dependent on each other, and quantum confinement should be understood in those terms, but nothing more than this. Okay, I mean, just zooming in, what about quantum cases? Okay, so quantum cases, we're going to go a little bit, focus on entanglement, because this is the work we already did. But here are some new things that, knowing that there will be some people in the audience, we actually put it forward for discussion. So the first one is, other possible cases is bundle ontologies for quantum mechanics, for some interpretations of quantum mechanics, have been explored as of lately. So the best instances of this, as far as I know, are relational quantum mechanics and the model Hamiltonian interpretations, especially by Olimpia Lombardi and Newton da Costa and Andrea Aldefredi for relational quantum mechanics. Here's the thought, is that quantum systems are just bundles of properties that are represented mathematically by particular kind of operators. And one traditional objection against the view is that you need to have a principled reason of why, for example, you don't see bundles that have only, let's say, a mass property or spin property or something like this. This is especially true in the case of model Hamiltonian interpretations, because the core view is that elemental systems are bundles of properties that commute with a given Hamiltonian. Now, symmetric relations of dependence will get you out of the problem pretty quickly, because you will just say that those particular properties, right, are symmetrically ontologically dependent, and therefore, whenever you have one, you're going to have all of them. So that's why you will never see a bundle which is not a saturative bundle. So this will get you out of a very powerful objection against these ontologies, which has been explored lately for these particular interpretations. Okay, so other possible cases. So here's Michael Esfeld talking about Bohmian mechanics. So here's what he says. I'm going to read it because it's easier for me. Wait, let me put you here. How do you do that? Okay, let's do this. Okay, so in Bohmian mechanics, the structure consists of a network of relations that relates the position of, strictly speaking, all the particles with each other. Okay, so such that the temporal development of the position of each particle depends on the position of all the other particles. Now, if you can make the claim, now, is this coherentism already? No, that's not coherentism already. But if you can make the claim that, for example, something depends on something else for one respect, therefore, there is a sense in which it depends on that thing, with the other respect, then it will get you coherentism even in this case. It's just going to be a two-line proof that gives you that. Now, I acknowledge that the principle I just used, that if I depend on Christian for my, I don't know, beauty, let's say, that I depend on Christian, like these are controversial principle that shouldn't be accepted lightly. But if you can find something like this, then coherentism will get you what you want also in the Bohmian case. Okay, but now the other one that we thought about was relational quantum mechanics itself, independently of the bundle theory ontology for relational quantum mechanics. So this is a beautiful quote from Carlo, which I think is in the audience, and Federico on the SEP entry. Okay, the notion of a substance that plays a major role in Western philosophy might be inappropriate. Perhaps the idea of mutual dependence can give us, let's say, a philosophical scaffolding. And then mutual dependence is exactly the signature of coherentism. Now, there's nothing more than this, and so we don't have here anything more to offer. But can I do a little bit of self-promoting? We will have Christian is one of the organizers as well. We will do an entire workshop on relational quantum mechanics with Carlo and Matteo and Mauro, which is in the audience, I think. I think we'll talk about this a little bit more in detail. But
I'm here, Claudio. I'm here.
Yeah, I think I saw you. Yeah. So this is So we'll stay tuned on the 25th. Wait, Paul, you had a question? I don't know how's the thing here. Do we go?
Yeah, I was waiting for you to finish the sentence and then ask Paul if it's a clarificatory question or. You're muted, Paul. So.
Yeah, I was intending to wait for the end. Yeah.
Okay, it's up to you. Okay.
Well, no, I'd let you finish because I don't want to throw it off course at the moment.
Sure. Okay, so at this stage, the argument is simply that symmetrical relations of dependence, right, can play explanatory roles in different scenarios, right? From metaphysics to philosophy of math, philosophy of physics in general, to really particular concrete cases in quantum mechanics. And now we're going to, before we move to the consequences, we're going to show the paradigmatic case a little bit, which is entanglement, which is the work we already did. So we start with just the toy example, just the singlet state. So even in the toy example of the singlet state, right? The singlet state supports counterfactual, robust counterfactuals, such as if we were to measure spin up for the first particle, we would measure spin down for the second. Therefore, there seems to be modal connections here. And if you just apply straightforwardly a very weak version of the so-called Hume dictum to the point that there are no necessary connections between completely independent entities, you get that whatever systems are there in the singlet state, they're gonna display some dependence relations. Now the question is, what is the shape of these dependence relations? And we just want to argue at first that coherentism provides an alternative to the most widely held view in the literature, which are structuralism and holism. Okay, and to do that, actually, we needed to go a little bit into the details of the relations of dependence, and we did that because the debate about bringing in relations of dependence for entanglement was initiated, I'd say, with a beautiful paper by Kerry McKenzie, in which she argued that this was the key to actually frame rigorously, structuralism. And so, and she has a particular version of a particular construction of relations of dependence. We're just following suit here. We just did more distinction because I think they're important. So usually what you can have, the different versions, right, of dependence depending on the shape that they take. So let me walk you through some important ones here. So the first one is that what we call rigid essential involvement. You just say that X depends on Y if necessarily, okay, X is related by R. There is an R such that X is related necessarily, is R related to Y. Okay, so there's a stronger one that says that, which is called rigid essential necessitation, that says X depends on Y if necessarily the existence of X requires the existence of Y. Okay, and then you can have different variations of that. I'm gonna talk about only generic essential necessitation because it's important for what comes next. So look at it, says that X depends not on Y but on a Y that is F. Okay, it means that X exists only if and only if necessarily it also exists a Y that is F. But it doesn't specify which thing it is. So this is the key difference, right? For example, from rigid essential necessitation and generic essential necessitation. With the rigid claim, right, you read, so X depends on a particular thing, okay? So I depend, let's say, on Christian. I depend on Vera. I depend on Carlo, or I depend on Mauro, okay? With the generic essential necessitation, you don't actually say that I depend on one thing, on exactly one thing, right, rigidly on one thing, but just on something that satisfies a description, okay? So for example, I depend on a philosopher that lives in Bern. Now it might very well be Vera, but it might very well be someone else, okay? And that's gonna be important later on. Okay, good. So, I mean, all else being equal, you can see that rigid claims are more informative than generic claims, right? Because they specify the object on which you depend among the one that actually satisfy a given description. Okay, and then for different reasons, which Matteo already went a little bit, which has to do with the distinction between naive and sophisticated coherentism, we also needed actually to, let's say, enlarge our logical vocabulary to plural logic and have plural variables. But we're really not going to do here in details, but they play a role as a matter of fact. Because I don't have much time and I want to go actually to the new part to see what you think about this. Okay, so, and in the paper, we used that just because Kerry McKenzie used it, and that version of dependence, right, which builds on the logical work of Fabrizio Correia, Keith Fine. I mean, the logic of that relation is already well studied. So, I mean, we just could borrow all the formal results from that literature. But of course, you should feel free to plug in your favorite, I mean, modulo certain details, your preferred notions of dependence here, particular understanding. Primitivism, just simple modal dependence, explanatory dependence, or even different ways of cashing out dependence talk in general, like Matteo mentioned, grounding. I think that Alastair Wilson now has something like with structural equation models and counterfactual dependence. Now we will just assume that dependence is a relation whereby something X depends on something else for, as Matteo put in, for some respect, like it can be its identity, it can be its qualitative profile, it can even be its existence. And of course you have to allow for conditional ontological dependence. I would say X depends on Y, provided that phi, okay? Provided a certain condition is met, in which in our case will be provided that the systems are entangled, okay? So these qualifications, I will not repeat it all the time, but it's actually is in the background. So because we are trying to account for entanglement here, okay? And as a matter of fact, we will end up saying that we will start from conditional generic essential involvement and then move for token claims to rigid dependence. So that's the move that we do, that we think it's not really possible in cases like structuralism and holism, which will give you that coherentism is actually explanatory. I mean, it's explanatory better, at least in certain respect. Okay, let us go through the most widely held view in the literature. So the first one is structuralism. So structuralism, as Lederman wrote it, is just a typically but a plank in a more structuralism about quantum entanglement is just a plank in the larger project of anti-structuralism, okay, which is any form of realism based on an ontological or metaphysical inflation that inflates priority of structures and relations. So now, as Kerry McKenzie put it, the thought is that in the entanglement case, and this is just for the toy model, we're just going to use the singlet case. But as a matter of fact, for our criticism, for example, for holism, it actually matters that we move from the two particle case to the many particle case. But in the case, just in the toy example, in which you have just two entangled systems, what the structuralist will say is that the symmetric and irreflexive physical relation that weakly discern the quantum system, okay, there are also those relations that the systems depend on. And this is what so the framework that we use allows us to frame this pretty rigorously. It's this claim. Necessarily, if the two systems exists, there exists a relation, a reflexive asymmetric relation between them. Okay, now, as you see it immediately, we wrote it that way so that you can see immediately that this has the right logical form of a dependence claim, and as a matter of fact, of a generic claim, okay? It doesn't say which relation. It tells you that there is just one relation that satisfies a description, which one is reflexive and symmetric. So you can see immediately that this is a dependence claim, and it's a generic one in that, okay? What about holism? So in the two particle entanglement case, what the holist would say is that there is a meterological sum, okay? So entanglement is at least sufficient for composition. There is a meterological sum, okay, of the two systems in question. And now the two systems in question depend on that sum. The usual argument that is found over and over in the literature here is just that, the state in quantum mechanics, the state of the whole always determines the state of the part. If you can attribute states to the parts, like if you have formalism, which is general enough to do that, like, density matrices or something, but the converse does not hold, then entanglement being the case in which the converse does not hold, okay? And the holists, for example, Jonathan Schaffer, Jen, and Ismail, which I know you had as a guest a few weeks back, want to say that the lesson we should learn from this is that the whole comes first, okay? So, and how to put it in our framework? Well, you're gonna the first step is gonna give you something like this. It's gonna give you that necessarily, whenever there are two entangled systems, there is a whole such that they're both part. And as you can see, even here, right, this has the right logical form of a dependence claim. I mean, we did it on purpose, of course. I mean, we did our own work, right? And this is a generic claim as well, okay? Because it says that there is a Y such that these are parts of it. Now, there are ways of making this rigid, we will see some. But every way of making it rigid, we think it's problematic. So, but as of now, we just want to argue that there is another option out there. This is not an exhaustive list. So, and first of all, let us say that they both require a substantive reading of the quantum state. So, for example, structuralists will say, oh, it describes a relation. And the holist will say, no, it describes a monadic property of the whole, okay? And as I said, it delivers at first tab, it delivers only genetic claims. And if they deliver rigid claims, so for example, there is a way of making this a rigid claim. Okay, so for example, say, not that there is something of which there are parts, say that there is a fusion, okay? It will easily, I mean, you could see immediately that if you want to take the most general case, you will end up actually very close to monism, like being that the whole, okay, the whole is the more encompassing whole, which means the whole of which everything else is a proper part, which in technical terms in meteorology is called the universe, okay? This is the only fundamental thing. And you might not want to be a monist for different reasons. So for example, because the monist argument, for example, cashed out at that level just breaks down for particular interpretation. For example, for relational quantum mechanics, because the monist argument, right? Remember that the state of the whole always depends on the state of the parts, implies that there is such a thing as the wave function of the universe, okay? And the wave function of the universe actually describes the properties of the universe. And we think this is in peculiar contrast with relational quantum mechanics. So you might want to resist that move, but if you want to deliver rigid claims, you're gonna have to go there. And now, apart from this, right, we might have some other reservations. So for example, it's unclear to us that structuralism as it is formulated, meaning like, oh, that, so let's take in the singlet case, like it's entangled in the spin degrees of freedom, the structuralists are just saying, oh, wait, I mean, the entangled system actually depends on, they're entangled in the spin degree of freedom depend on having opposite spin for their spin profile. Or there's another worry here that it's just restating the Pauli principle. Why? Because from the Pauli principle, it seems that you can actually build easily enough, right, a symmetric and yet irreflexive relation, which is the following, having a different value for at least one quantum number. Okay. And then I already said something about some reservations about holism. And there might also be some reservations about fine grainedness, because there are cases, for example, in which you have more than one entangled particles, such that, I mean, systems or particles, whatever. These are just placeholders. They don't have really to be particles in the metaphysical sense here. So, for example, in which the first system is entangled in the spin degree of freedom on the second is entangled for the position degree of freedom with the third. And it seems that at best, all it can say, without actually mentioning parts of the whole and relations among the parts, right? Which he can't, because its fundamental ontology has that. So it just has to say that all of the parts actually depend on the whole. So we think that you lose a precise information. But so I mean, these are not clearly don't knock down arguments. The thought was that just, okay, there are some difficulties here. Is this an exhaustive list? Does it exhaust the possible metaphysical underpinnings of entanglement? And we want to say that coherentism provided an alternative one. And roughly, well, to put it roughly enough, the right conclusion to draw is that it's not that the physical relations are prior, okay, to the systems, or that the objects depend on a more fundamental whole. Rather is that when they're entangled, provided they're entangled, right, one system depends on the other system for a particular degree of freedom, the degree of freedom on which it is entangled. Okay. So, and you start, technically speaking, from the insight that the entangled systems are essentially related in some generic way. Now, look at this claim. This claim is not the claim of structuralists, as a matter of fact, because it does not have the right logical form. The right logical form of the structuralist has the symmetry, the existence of the quantum systems on the left-hand side, then it has on the right-hand side the relation. This just says that whenever they're entangled, there's an essential relation. Okay. Now, once you recognize this, structuralists go a step further and say that that relation here also plays the role of the first relatum of the dependence relations. And this is where the structuralist and the coherentist part ways. That we don't want to go there. We just want to start from these notions of dependence and then move, right, make a move that has been made in the metaphysics literature by, for example, Keith Fine says, right? It's sometimes, and I'm just going to read it here because it's easier. Okay, wow. Well, okay, it's sometimes thought that objects whose nature can be understood in terms of one another, in addition to possess constitutive essential properties, will also enter in constitutive essential relations. And let us therefore say that an essential relation between the two is irreducible if it is not a logical consequence of the essential properties of the objects considered separately, or the essential relations among this joint subset. Two objects may be taken to be reciprocally dependent under the present, that doesn't matter. It mattered for us, but for technical reasons, just in case they stand in an irreducible essential relationship, okay? And that's exactly what we're saying here in the case of entanglement, right? So we're gonna say that once you recognize they stand in that relationship, okay, what you have, because it's essential, because of course, the relation doesn't supervene, or it's not a logical consequence of the properties of the systems actually considered individually, right? What you get, and in quantum jargon just means the probability distribution of the relevant degrees of freedom does not factorize, okay? And this ensures that you're actually, the coherentist analysis actually targets exactly the cases of genuine entanglement that is called, sometimes in the literature, called the Girardi-Marinato-Weber entanglement, which is the entanglement that is not just simply due to antisymmetrization. And what you will get if you go like this way is just this claim here, that provided they're entangled, the systems depend on each other, which is the claim that I just wrote here. So you start from necessary involvement, okay, in the most general sense, right? And then for particular token cases, once you give me a particular, let's say, quantum state, like a particular quantum entangled state, then I can tell you, then I can run the analysis for tokens, okay? And I can deliver rigid claims of dependence here. This is not actually, as you should be able to see that this is not a generic statement of dependence. This is actually a rigid claim of dependence. And then, of course, in the cases in which you have more than one, you'll have to complicate the story a little bit. But in the singlet case, that's what you get. Okay, good. And this is, I'm going to skip, I'm moving real fast because I think we're out of time. And these actually, so this was to say that when you have this particular, you have more than two systems, right? What you get the sophisticated coherentism that Matteo already talked to us about, and what you get the sophisticated coherentist, for example, which is the counterpart in epistemology by the position by Bonjour. And the argument here is simply that coherentism, right, is a genuine alternative to the standard interpretation. It delivers different claims of dependence, okay? The relata of the dependent, so, right, it delivers generic claims in general instance, but rigid claims when you give me token examples, okay? We will see that this is important. And then it's different from structuralism because the relatum of the dependence relations are not relations on the one hand and systems on the other are just systems. And it's different from monism, because even if monism or holism, has both the relata are, let's say, systems, right? You don't have wholes. And this is important because it's a substantive question whether things compose something else, okay? Coherentism is fine, not even if there is no mereological sum of the quantum systems to begin with, which you might actually want. So there is a literature now on quantum mereology, whether actually there are quantum counterexamples to fusions axioms in mereology. Okay, so now that doesn't mean that it's the best, it just means it's an alternative at this stage of the argument. Now, in the paper, we go as far as claiming there are some things to be said on coherentist behalf. It strikes a balance between structuralism and holism. It incorporates insights from both, right? But the dependence relation can hold between physical systems, and you have to actually allow for essential relations. But it steers clear, right, of more controversial theses. For example, that in the case of mereological composition, the dependence relation always goes from wholes to parts. So it's explanatory. So we used it actually to underwrite non-causal violation of outcome independency in Bell's type scenarios. It's informative because once you give me a particular state, it gives you rigid claims of dependence, such as system S1 depends for the spin degree of freedom on systems S2, whereas S2 depends on the position degree of freedom, system S3, which we think, for example, holism will have a hard time recover. Structuralists might be a little bit better off here. And of course, I mean, as you can see, right, you should see that there is no conflict, right, with the generic claim that we started from. This is not entanglement now. This is a particular token of entangled systems, like let's say the one in the quantum state, in the singular state. And of course, in the paper we go, we discuss some subtleties about entanglement, maximally versus non-maximally entangled state, and we show that coherentism can allow for such a distinction. And then we go on entanglement distillation, in which you start with a bunch of systems that are entangled, only a part of which is entangled. Then you distill the entanglement in a subspace, in subset of those, or you can dilute the entanglement. Like you can actually spread the entanglement over more parties, and you can swap entanglement. Like you can swap the entanglement between system 1 and 4 and 2 and 3 with 1, 3, 2, 4. And we show that coherentists have the resources to explain all these nice subtleties about entanglement. And then if you want, you can also add a conservatism argument to the point that coherentism can say that, for example, I depend on Matteo for my, let's say, position degree of freedom, because we don't want to be more than 5 meters apart from each other because we love each other. But at the same time, we can retain like, you know, good old-fashioned traditional mereological dependence from parts to wholes, for example. If you, should you want to, you don't have to, okay? Now, so that was actually our case for, you know, quantum coherentism in general, quantum coherentism in particular, coherentism for quantum entanglement, even more in particular, more focused. Now, for the last part, and then I'll leave you alone, I promise. We're gonna give you the consequences of that. So if you're with us, that it's at least an option worth considering, because as Matteo was pointing out, like there is basically no paper around about that, about mutual dependence relations, beside ours, I would say, in philosophy of physics at least. So what are the consequences? And I know that we already done a lot of metaphysics, but I think it's an interesting case here in which the consequence for metaphysics and philosophy of physics are related. So we have to go through the consequences of metaphysics to tell you something about the consequence for philosophy of physics, which might interest most of you, which we think it has an important consequence for a position which has been recently defended in quantum metaphysics, which is wave function realism. But first, we have to go through a little bit of more just pure metaphysics-y talk. Okay, good. So, and here, let's go back with what Matteo said, right? So coherentism could undermine the foundationalist hierarchical picture of nature, right? It could actually just undermine the view that nature comes structured in different levels of relative fundamentality, okay? It just can be done with that. But yet, it's an important point that it is compatible with such a view. Now, I am going to provide you a proof of concept, which I did in an afternoon. So this is not supposed to model any real-time case, any real-world cases. But this is just a proof of concept to let you, to show you that it can be compatible with such a picture, but it will still undermine main tenets of foundationalism, and this is important, okay? So for the toy case, let D stand for dependence, whatever dependence relation you might want, and this guy stands for more fundamental than, okay? This is the relation X is more fundamental than Y, and F, as Matteo just already introduced, is just absolute fundamentality. It's just, this is absolutely fundamental, okay? Now, technically, we did it for facts, because facts are fine-grained propositional entities, but nothing hinges on that. So I will just use facts just because I did it, the formal work I did it for that. Okay, so now you give me a set of facts, okay? And now I define a set theoretic partition on those facts. That is, I'm going to define subsets such that they're pairwise disjoint and the union is the set that you gave me. Okay. So here's the toy model. So I'm going to define, and the subsets, I'm going to call them levels, which were, they're supposedly the counterpart of levels of reality. If you want to still hang on to the view that reality comes structures in levels. Okay. So I'm going to define a relation of the level I is more fundamental than the level J, just by using dependence. And I'm going to say that for every fact in the first level, in the second level, in LJ, there is a fact there is a fact, this should be in Li, okay, such that the second fact depends on the first. Okay, so you give me one fact in one level, I give you a fact in another level such that there's a dependence relation between the two. Okay, good. So now I'm going to define, this of course is a relative fundamentality talk. It's a relation between levels. I'm going to define absolute fundamentality for levels the following way. FL is the fundamental level, okay, if and only if there is no level such that it's more fundamental than this. This is just, I mean, this is just supernatural, right? And now I can piggyback on these relations, right, to define the target notion that we want to define. Fact one is more fundamental than fact two, and fact one is absolutely fundamental. Or entity one is more fundamental than entity two, and entity one is absolutely fundamental. And here's what I did in 15 and 16. So I'm going to say that fact one is more fundamental than fact two, simply by saying there are two levels, okay, if they belong, basically, let me just go quickly. If they belong to different levels, okay? This is just what 15 says. So 15 defines a relation between entities, piggybacking on the relation of relative fundamentality defined between levels. And now I can also define a notion of fundamental fact or fundamental entity just by saying that it's a fact that belongs to the fundamental level, okay? And now this is a toy model, but this is completely compatible with coherentism. You can just check that it is compatible. And I suspect actually it is the naive picture that some particle physicist has in mind. So here's the Kane introduction to particle physics, which says, oh, you get me quarks, I'll give you hadrons, okay? Then you build from atoms, from hadrons you build nuclei, from nuclei you build atoms, from atoms you build molecules, and then the hierarchy of structures in nature is built, okay? That seems actually very, very, very similar to what's written here. Now, I don't think that anyone should hold this particular view, but there are actually more complicated and more sophisticated view in the vicinity. You will have to tweak the formal work to ensure that, for example, so these you can just verify that it's a strict order. In other cases, you don't get it for free and you need to do some formal work. But for us, the toy example will do, okay? Okay, why is that important? Because this is all compatible with coherentism, and yet it still undermines two widespread theses in the vicinity of foundationalism. The first one is that fundamentality for entities is absolute independence. And this is important for the quantum case, we think. So here's the definition of fundamentality for entities or facts, just as independence. And this is the orthodoxy in literature, okay? That just says that a fact is fundamental if there is no other fact such that the fact depends on this. Okay. Why the toy model actually is incompatible with that? One, it's because nothing precludes at the fundament, because the definition I gave here, right? The definition I gave here, 16, just says that to be fundamental fact, you belong to the fundamental level, but nothing clearly precludes that there are dependence relations between facts at the same level. Okay, and as a matter of fact, coherentism for the fundamental level will give you exactly that there will be dependence relations between facts at the fundamental level, but there will still be fundamental. So coherentism with the toy model I just gave you will actually falsify this, which we think it's very important. And it will also falsify that dependence always tracks relative fundamentality, right? And you should, and this is a good result, right? Because coherentist clearly want 18 to be gone. 18 is just a conditional that if F1 depends on F2, then F2 is more fundamental. If I depend on Chris, Chris is more fundamental than me. Of course, coherentism should want this to go away, right? Because they want, because, you know, given that more fundamental, then it's probably a strict partial order. It induces a strict partial order. But coherentism cannot say that dependence induces a strict partial order because it gives up antisymmetry and asymmetry. Okay, we want this to go. And of course, this in the toy model has to go as well for the very same reason. Nothing prevents dependence relation to obtain between facts at the fundamental level. Okay, for those two facts, given that they will be at the same level, they will be equifundamental. There will be each of them will be as fundamental as the other one, but there will be dependence relations between them. Okay, and these we're going to see. It's very important. And in effect, if you go as far as this, okay, so here's the most speculative bet. Here's a jump. Okay, so if you go, if you are with us as far as this point, I think we can go a little bit further and say that coherentism really side with a complete different. If you want to hold on to the hierarchical picture, you might not want to do that. Then you jumped ship a little bit. I mean, this part of the talk was pitched for the ones that still want to believe that there are levels in nature. Okay, but even in this case, coherentism will provide a completely different picture than traditional foundationalism. And here's why. Traditional foundationalism holds on to 17, okay? And it holds on to 17 because usually we attribute two theoretical roles to fundamental things. They're unexplained explainers, okay? There are things that they're not explained by everything else, but they do explain everything else. So foundationalism is very close to actually the unexplained part. These are independent things insofar as they're not explained by anything else. We just told you that coherentism, right, probably will give up this, even when framed in a picture which retains levels of nature. Okay? And as a matter of fact, we think that it will favor actually focusing on the other part of the theoretical role of fundamental entities. It's not important that unexplained, that there is independent. The important fact is that they explain everything else. Okay. Coherentism seems to say, look, give me hold the coherent bit, right? So suppose that the fundamental level is a coherentist level, right? In which there is, just looking at the boxes that I have, is Paul, Christian, and Matteo. Let's say that these are the three things at the fundamental level, right? And they mutually depend on each other, right? They can still do all the work, the theoretical work we want fundamental things to do. If we just relinquish fundamentality's independence and we say, oh no, fundamentality is not independence, is actually everything else depends on those. Okay, that's the key. And we think that coherentism sides well with this notion of fundamentality, which actually is a radical departure, even in the case in which nature comes stratified into levels from traditional foundationalism. Now, so this is already the consequence for philosophy for metaphysics. Okay, it will side with this notion of fundamentality that has been largely explored, and of course now we are doing some formal work to see when these two notions, the being independent and being such that everything else depends on that, come apart. I was supposed to do the formal work, but I got distracted, so I just got up to a certain point. I think it's necessary that it's a strict partial order. So of course, coherentism will drive the two notions apart. Why is this important for philosophy of physics now? Okay, so we think it's important because it can give us reason to undermine what is being called by Alyssa Néel, which I think you had her as well, right? No, okay, well.
No, she came for the conference, but.
Oh yeah, she came from the conference. In the book which just came out, The World in the Wave Function, and the master argument for wave function realism, which is roughly an ontological picture for non-relativistic quantum mechanics. Alyssa is very clear that when you move to relativistic regime, you will have to actually do some adjustments, and not easy ones at that. But for non-relativistic quantum mechanics, you can just put it in the form of a slug, and the wave function represents a fundamental field in configuration space. Okay, And this is the master argument Alissa puts forward in the book. After going in the first 2 chapters on different arguments that have been with us in the literature for a long time, such as success of wave function representations and entanglement as well. So here's the master argument. This is in chapter 3. Having a fundamental ontology which is both separable and local is a desideratum for any ontology. This is an assumption. Second assumption, the only fundamental non-relativistic quantum ontology that is both separable and local is wave function realism. Therefore, all else being equal, we should endorse wave function realism. Okay. So this is the master argument. Now, why the metaphysical consequences of coherentism actually are important for evaluating this argument? I mean, this is the new part, which we don't know whether we're completely off track. Just tell us that if we think we are. Because the argument is that it seems to us that you get P1, you get the separability, which we're going to see a formulation right now. It's a desideratum for your fundamental ontology, if and only if, I mean, this is not the logical if and only if, the reason why you want your fundamental ontology to be separable is exactly because you think that fundamental things are independent things. And as a matter of fact, this is the standard formulation by Howard, which is quoted in Néel, right? So separable, I say, 2 subsystems. The content of 2D separability is that the content of any 2 space-time regions are separable if and only if each possesses its own distinct physical state, and the joint state is completely determined by the state, by these individual states of the subsystems. Of course, it seems clearly that what separability actually ensures you is that the subsystems in question are independent. And as a matter of fact, I think historically Einstein actually cashed out some sort of this principle exactly in terms of dependence and independence of physical systems, but I might be wrong. So surely, if you believe that fundamental, so here's the train of thought. If you believe the fundamental items are independent items, then you should want your fundamental ontology to be separable, right? Because separability will ensure exactly that. But as we saw, coherentism, right, is a way of actually denying that, gives you a way of denying that fundamental entities, if there are such entities, okay, should be conceived as independent, okay? What we should be conceived as that everything else depends on those, but those don't have to be independent. But if so, right, so to wit, this is just to repeat, separability ensures in effect independence of the subsystems, but coherentism, if now one relinquishes fundamentality independence, one loses the most compelling, if not the most compelling reason or motivation to endorse fundamental separability and thus P1. If you don't have the view that fundamental items should be independent items, there is no reason to have separability as a desideratum for your fundamental ontology, and therefore you don't get the first premise of the master argument for wave function realism. And if putting it all together, it seems that coherentism actually has a nice application now, also in a hotly debated question in another debate in quantum metaphysics, that is, it might give you a way of undermining the master argument for wave function realism. Not the only one, of course, but it's just we think it's a nice one. It's a nice one actually that depends on the metaphysical work that coherentism can do for you and give you a different perspective on the architecture of realism. Okay, so and just to conclude, so we did a lot of metaphysics. Sorry about that. And so we did philosophy of physics, and to conclude, let's talk about more important things, which is, so this is all me, so don't blame it on Matteo. So this is all me. So this is the new edition of John Donne's poems, which just came out, which is a beautiful edition. And in this book, I mean, this is the first, okay? So in which you have also, as you can see, the love poems that he wrote before he was Dean of St. Paul, and the elegies, and one very famous poem that you have here is the Ecstasy, right? So the axis is a famous point for coherentists, let's say, because, so we reproduced 4 stanzas. So because usually it is taken, these last 2 stanzas, they are usually taken to actually argue, let's say, in favor of the symmetric dependence of body and soul. But we want to be misfits in this case as well. We want to focus on the first 2, actually. So the first 2 describes the metaphysics, the mechanics of love. The mechanics of, and the entanglement of souls once love enters the souls, okay? And so, and you can see, right, the love interanimates 2 souls, then the effects of loneliness controls, which is such a beautiful, these are such beautiful stanzas. And well, I won't read it, but so here's why we think this is important, right? Because we think that actually John Donne is such a deep thinker that you can actually find traces of all the explanations we actually talked about in the case of entanglement. So here's the thought is that you have 2 souls, love enters them, and love animates them in such a way that they construct another soul, which doesn't change, as a matter of fact, as you can see, of whom no change can invade, which is a topos, I think, in Elizabethan poetry. Like, so you might remember, Shakespeare, like, love is not love, which alters when not alteration finds, okay? And then you can run these 3 actually explanations, right, for the mechanics of love and entanglement of the souls. So here's what the holism will have to say. And the good thing is that all of these explanations, you can find hints of all of these explanations in the stanzas by Donne. So here's the honest explanation. Love composes a new soul, the unchanged one, okay? And the 2 souls depend on the new soul. So here's what structuralism has to say. Love, when it enters the 2 souls, and the atomies, as you pointed on the 2 souls, relates the 2 souls, and both the souls depend on love, okay? On love itself. And then here's ours, which the 2 souls, when related by love, okay, when they're in love, they depend on each other. And now we are partial to the coherentist. I'm partial on the coherentist explanation, also in the case of love. But that's me, and with that, thank you guys. Should I stop sharing?
Yeah, for now, yes. And then
we can see each other.
If someone asks. Thanks a lot, both Claudio and Matteo. Wonderful. I really enjoyed that. So I have, I have polled since a little bit, but Giuliano asked me to go first, if you don't mind, Paul, because he has to leave early. So
yeah, sorry guys, I have to go. And thanks, Paul, for letting me. Yeah, that's a question about. So I guess that links certain things in the first part with the other things in the second part. But so you wanted to. So in the first part, you sort of make it clear that you wanted to stress that your position can resist any charge of being explicatorily vacuous or circular in a bad way, at least. But this is here the idea is that it's the position that as explicatory power, and that's it's orthogonal with respect to whether the specific dependence relation that you pick up has explicatory power. At least as you present it, that seems correct, because you want to be neutral with respect to which dependence relation to pick up, and not all of them have explicatory import, right? Now, I was wondering, and that's connect with something in the second part, especially with respect to the compatibility with the letter, but not with the spirit of nationalism. I was wondering, so if one could read your position as one in which there are so when the relation of dependence is symmetric, it doesn't have explicatory import. That seems to go in the direction of your first remark that you say when you say that, oh, but it's bad when the explanans depends on the explanandum and vice versa, not when the mutual dependence is in the explanans. And because it seems that, well, then if it's like that, no, then in the explanans, the dependence relation has no explicatory import. It's just like, let's say, counterfactual dependence, or any relation that just gives you a correlation between behaviors of the entity. What is important is that then the fact that there is this correlation explain other stuff, no? I mean, if you see it in this way, then you have a picture which is very close to a foundationalist picture, in which it's still true what you said in the second part, that the formal properties are different. For instance, you don't have reflexivity and things like that, irreflexivity and things like that. But still, the third point that you had in commenting the compatibility with the foundationalism would not hold, no, because in that case you would have that the elements at the fundamental level are explanatorily are unexplained. So you have dependency relations, mutual dependency relation between the elements at the fundamental level, and those are just brute facts. It's not that there's any explanation between it's just that there are those dependencies. And the fact that there are those brute facts explain all the rest. But that looks much more foundationalist than you want to, I think. Okay, I hope that has been clear.
Claudio, shall I go first? I'll try to answer the first part. Let's see if I understood you correctly, Julian. Okay, there are two replies that I gave to this obvious objection word. It seems to me that they are connected, so let us see if they are. It seems to me that if you have reflexivity of full grounding or full dependence, then in a way you don't leave any room for ontological wiggling with other things. But you need this room in order to make explanations non-trivial. So let me put it this way. You focus on the explanans. Within the explanans, you can posit any sort of relations you want. Grounding, ontological dependence. It seems to me that whatever you use, if it is fully reflexive, in the sense that in the end, you want to explain A and you go back to A, and all the rest can be set aside. You go through it and then you ignore it. Then you have vicious circularity. And in that case, there is no space to then build an interesting explanation by adding something else. So this is the thought. While if you have only partial dependence, then of course, it could be a bad explanation after all. It is not sufficient, but it is necessary. So that's the idea. You want to have partial dependence, and then you have to build the right story. And that's why we spent all this time thinking about specific versions of dependence for specific cases. If you don't get those right, then even if you have partial dependence, it could be not sufficient for actually giving something to people interested in quantum mechanics. So this is the general story. For the second part, I think Claudio made it clear, but well, Claudio, you go ahead. We are not against foundationalism altogether. Yeah, Claudio.
Yeah. So yeah, let me take the last part, which I think as Matteo suggested. I mean, we're not we're not completely against foundationalism, but and there's a way of making it, I mean, compatible, let's say, with the hierarchical structure, right? The toy model I gave, right? Now, that doesn't mean, so it seems to me though that, I mean, the compatibility is at a different place from which you pointed out. Because you might very well be, right, you might very well have even like relations, symmetric relations of dependence that support, actually, as a matter of fact, nothing prevents you, that support the explanations, partial explanations, right, as Matteo pointed out, even at the fundamental level. Perhaps you want to say that, I don't know, perhaps you want to say that, you know, really the existence of one quark is grounded in the existence of the other. And you think, now, and those things, so the things at the fundamental level, right, they will be actually, they will not be unexplained. So this is a point of departure. The point of contact will be there. Then in those pictures, there will be fundamental entities. That's true, right? So with the traditional, we will agree with the traditional, let's say, picture of foundationalism in that respect, that there are fundamental things. These are the ones that belong to the fundamental level. But we will not actually agree on the foundationalists that those things are unexplained. I mean, we might not want. That depends on the right relation that holds. I mean, of course, if there is no, let's say, explanatory backing, I mean, no relations of symmetric dependence that backs up explanation, that they will also be, okay, unexplained. But nothing prevents it to be. So there is, as a matter of fact, one point of contact with traditional foundationalism, but it's just in the existence of fundamental entities, I think. It's not on the unexplained part. There might very well be that they partially explain each other. So the existence of the fundamental entities will be a point of contact, but not the unexplained. So I think you're right in saying that the last part, I mean, will get you closer to foundationalist picture, but I would tend to disagree that so it's not in the unexplained part, I would say. It's rather in the existence of fundamental things part. But that's me thinking.
No, but I mean, I got, if I just, so I got that you are not compelled to say that they are not explanatory, the relation between the fundamental entities. I was just wondering whether you can, you know, it would be more economical in a sense. So I wonder if you really need the explanatory relation at that level and not just simply correspondences of behavior and where you need explanation is just going up, so to say. But okay, well, I see.
Yeah, but for this, I think Matteo is completely right. I don't think, I mean, I don't personally have a general recipe. I think we should go case by case here, and depending on what your entities are on the fundamental level and what relations. I think that in this case, in these complicated cases, just give you a picture. It's just like as much as I enjoy doing formal, you know, toy models, there's so much you can get.
Thanks.
But anyway, the most important thing is not to worry only about mereology, right? It seems to be, you know, lurking behind your question. You know, what is really in need of an explanation is the whole structure of the world. You know, the little things doing the big things. And this is the driving force behind foundationalism. And we are happy with that. I mean, if you want to have a mereological story, it's not going to be a coherentist story. But there is a lot more to be explained. The qualities of things, their identities, their behaviors. And I'm not sure I would agree with you that, you know, those things you can just leave them there. You know, there are correspondences of behaviors. Of course, you can go that way. If you cannot find a law, you can be a union and just say, this is the way things are. What we are not convinced about is that whenever you don't have a traditional story, mereological story, foundationalist story, then you don't really have the need for an explanation. We think you do have the need until you can prove that you don't get an explanation in any way. And in this case, mereology is going to be traditional. We are talking about different explananda.
Okay, got it. Thanks.
Okay, next one is Paul. You can go ahead.
And bye, sorry, I have to go.
Ciao, Giuliano. Thank you.
Sorry, ciao. Go ahead. Bye.
Paul, you're still mute. But I keep muting people, and I'm sorry.
Okay, no, okay, I'm back on that. So look, Yeah, really interesting. I think it's a very interesting conceptual space to be exploring. I've got a few things to say. I'd like to start off with a brief question as to whether you've thought about any relation of this to the particle democracy, Jeffrey Chu, the 60s, early 70s, when there was the debate about whether, you know, we went to quarks or not. It was Claudio's remark about quarks, which made me think of it, really. I mean, it was quite strong at the time. And then what happened was, well, the quark theory was adopted, so it was sort of a blow for, or a victory for fundamentalism, if you like. Well, so first of all, I mean, do you know about that connection at all? I mean,
so I happen to, I mean, this is recorded, right?
Yeah.
Which is not a great way. Which is not a great way to start.
What are you gonna say?
No. So I know of a connection, of a very interesting connection, as a matter of fact, with S-matrix theory.
Right. Okay.
Exactly.
Yeah.
So Kerry McKenzie wrote a paper on that, and she argues that, for example, it's infinitism that gets. So it's the other alternative. I mean, it's the other alternative to foundationalism, the one in which you give up well-foundedness. Right? Because each hadron was supposed to be built by an infinity of other hadrons. Now, as a matter of fact, I tend to agree with you that it should be a coherent story. It's the particle democracy thing. And I know I've been, I mean, a book is about to come out that actually will make this point. It's not by me. So there will be, I think that there will be, you know, space to make that argument. I mean, the book that is about to come out will tell you the infinity story for S-matrix. But I think that the right story to tell is a coherentist one, as a matter of fact.
Okay, so fair enough. So then another thing I wanted to say is quite early on, talking about the idea of how the coherentist, or that sort of family of approaches, has been neglected. And in a way, I think you could say the reason why it's been neglected is just because of the victory of the quark idea in the 70s. I mean, because, you know, oh, look, we're down to another level, sort of thing. So, and what I wanted to say is, I mean, I suppose I'm sort of working very much in a sort of fundamentalist tradition, if you like, but at the same time, I don't think one has to characterize it as being an overarching sort of trying to say the way the world is sort of thing. I mean, and I appreciate that you're, you know, you're saying that the coherentism is compatible with it. I sort of get that point. But in a way, I think when you're in a situation, and I mean, you're trying to understand entanglement and that sort of thing, well, particularly entanglement, is you're in a situation where you're sort of groping for ways to go. And one way is to explore the coherentist approach. Another way is perhaps to just hypothesize, well, maybe there's another level. You know, maybe when we've got if ever we get an accelerator big enough to find out how quarks are constructed, if they are so constructed, maybe there is another level, and so, but then that's not to say there's another level after that or another level after that. You know, in a way, I do get the impression that you might be, in a way, committing the sort of sin that you're accusing fundamentalism of trying to say, well, this is the way the world is. It's, you know, coherent is the way the world is, and characterizing fundamentalists as saying, well, you know, that's the way, it's levels of the way the world is. We should be more modest. We should just say, here's a problem situation. Let's go with this hypothesis, go with that hypothesis. Let's go with both. We're not, you know, there are plenty of people to explore both, you know. So that's, I suppose that's my reflection on the situation, yeah. Would you say that's fair?
Yeah, well, I think it does sound fair, but on the other hand, there is a problem in philosophy in deciding how you want to go to provide answers to questions, right? Suppose you want to be, well, we all want to be naturalists, right? So you take your science seriously, and if you want to answer questions about the fundamental ways things are, you look at your best actual science, right? So this is the thing. Obviously, you have something you cannot explain, like, you know, these violations of Bayes inequalities, these non-local connections. Of course, you can say, well, this means that physics is incomplete. But this has been a mistake in the past, right? Just hoping for some developments in the future, sticking to your preferred metaphysical view and wait. So we are just doing this, the other part, you know, until you get the new physics. This is the physics you have, and this is one possible way. We didn't say the right way. One possible way of making sense of it. And then, of course, it only makes sense of it if you buy into metaphysics vocabulary, but this is another problem, because if you're a foundationalist, you do it anyway. So you need to have a clear reason for not buying into this project. Maybe you don't like symmetry, independence, but again, you know, this is just presupposing foundationalism. So we don't want to do that. It's not that we say it's wrong. It's not that we say this is the final physics. No, it's just a temporary project for making sense of what we have.
Right. Yeah. I mean, I get that, and I think that's fair enough. We should. I mean, each individually we have different intuitions about things. Sure. One needn't be accepting something because it's an established doctrine. It might be just because, you know, that just for whatever reason seems to be the right way to go in current circumstances. But yeah, I mean, it's total liberalism in terms of which way your research is to go. I agree. Yeah.
Okay, so Dustin, you're up next.
Hi, hope you hear me. So first, thank you very much. It was really a wonderful talk, especially since it's a rather abstract topic and it's not really my area of expertise, and still I found it very clear and nice to follow. And I have just two somewhat related questions / objections, maybe. I had the impression that you were relatively non-committal with respect to what the relevant properties are that, but for which these partial dependencies hold. But your go-to example, or one of your go-to examples, was spin, right? And indeed, if you want to say if two electrons are entangled with respect to their spin, then you know the spin of the one is partially depends on the spin of the other, and that would admittedly fit well with how many people talk about quantum mechanics, but I think it's wrong nonetheless. So what's clear is that if they are entangled in this way, then you know the outcomes of spin measurements performed on the particles will be correlated. But I think it's well understood nowadays that the measurement process plays a very active role in bringing about these outcomes, and that it would be a mistake to think of spin as a pre-existing property that the particle possesses or that the electron possesses independent of the measurement process. So I find it a bit, yeah, I don't know, disappointing sounds like too negative, but yeah, disappointing that on the one hand you do such sophisticated metaphysics, and on the other hand you seem to adhere, at least in these examples, to a naive realism about quantum observables. And the second related point is that I think in Bohmian mechanics it's most clear how entanglement actually manifests, right? That the velocity of each part of any particle depends on the position of all the other particles, and I'm not exactly sure how to map this abstract structure that you talked about onto this example, right? For instance, it's not a relation about it's not about dependency relations between velocity, for instance. I mean, no one would say that the velocity of a particle partially depends on its own velocity, but the velocity of a particle partially depends on its own position. That is true, but it's not something that would even come under suspicion, I think, of a circularity or anything like that. But maybe I just have to think more about how your proposal fits with Bohmian mechanics. But maybe it could be helpful also for you to clarify this.
Matteo, you want to go first, right? Go.
No, you go first.
No. I can answer the second because I have thought about this.
Oh, okay.
Okay, I'll answer the first then. I think we do agree with you. We cannot be naive realists when we discuss quantum properties. The thought was maybe we were, too naive in doing this. We were sticking to very simple examples to drive the basic idea, but this is always dangerous, and we agree with you. Let me see if rephrasing it pleases you. I mean, it's not a discussion about specific properties. So the basic distinction that we drew at the beginning is between observables, right? So you have a theory and you have observables, and these observables are supposed to be in a one-to-one correspondence with properties out there. And this is the thing that if you're a realist, you want to reify. So these are real, right? So the basic claim is not about these things. It's about entanglement, and it's about ways in which these properties are exemplified. So actually, we don't care about spin. Our point is that if you want to reify a relation, as structuralists do, you're doing something really extreme, because it's not a physical constituent. It's actually a way in which physical stuff, properties mirrored by observables, exist. It's actually a fact about states, right? And this is why you want to resist reification. So just forget about spin. That was a toy example to show that the key point that we are trying to make, it's a point about what the theory tells you about states, about the ways in which systems depend on each other. And then you can use all the examples. And I agree with you that once you propose a toy example, it is potentially misleading. But our point is not about being a coherentist about spin. No, coherentism is a claim about states and ways in which systems are connected to each other as mirrored by the states as described by the theory. And I think this fits with your demands at the beginning. Don't be a naive realist. Don't presuppose anything about measurement. We totally agree with you. If you stick to the formalism of the theory, it tells you that the states are not independent. That's it. We stick to that. And then, yeah, you're right. I told you already 3 times. You're very right. It's not a claim, a simple claim about actual spin values. In particular, we are not presupposing spin values before measurement. That would be horrible.
Yeah. Okay, thanks. No, I understand. So it's best to think about these partial dependencies as dependencies between quantum states, so to speak.
I would say that.
Probably.
I hope Claudio agrees. Maybe he doesn't.
I completely agree. As a matter of fact, I've been pushing the line in print for a long time that actually it doesn't make, so in these cases, it doesn't make any sense. There is indeterminacy exactly because the particles do not have precise values. So it would be bad for me if I say that, because I would contradict what I've written in print. So it's exactly how Matteo, so it was probably my fault when I phrased the, but if you go to the point, right? You remember we start with necessary involvement, which is a relation, right, between the systems, which is encoded by exactly the state. And then the move that you make, you can make it exact. I mean, technically speaking, you can make it exactly because that relation, doesn't actually, it is not grounded in, oh, I have this spin, he has this spin, and they are anti-correlated. It's exactly because you cannot make that move that you can make the coherentist move. So it's not only that we don't do it, we're not allowed. Like if that, because it has to be essential an essential collective relation in fine sense. So if that was the case, we couldn't even move to the claim of essential necessitation to the claim of rigid dependence between states. So you look at the state, because so it's repeating like and putting some details on what Matteo said. So even from the metaphysics point of view, just the straightforward metaphysics, if we were to subscribe to that, to what you said, Dustin, I mean, the whole project will crumble down, because then we will not be able to pass to the coherentist, actually.
Okay, I completely understand. I just missed the point of the example, right? But we seem to agree that the claim cannot be that the spin of one electron partially depends on the spin as an intrinsic property also.
Yes, exactly.
Yeah.
Otherwise, and that's just, you know, when you use these toy examples, it's always like the second one. I think you're completely right, and it's so we put the Michael Esfeld quote because he said that very nicely, right? But the good thing to as you pointed out already, right? It doesn't give you in and on itself. It has some coherentist flavor, like, oh, the velocity, you know, depends on the position of every other particle. That sounds coherentism, but it's really not, right? As you pointed out. I mean, first of all, because you have a velocity that depends on the position of the other particle, and you don't have the position of the other particle depending on the velocity of one. So you don't get the symmetry which you need to run the coherentist story. So you're really right that there's some more work to be done here. So here's one way, but this is very tentative. So if it doesn't turn out to be true, suppose I can have some principle such that, suppose that I say that if one of my qualities, let's say, depends on one of Paul's qualities, right? I can make a claim that, you know, I depend on Paul for one respect. And if I depend, and then second principle, if I depend on Paul on some respect, I depend on Paul. Now, if you
you mentioned that in the talk. I didn't put it together. Yeah.
Definitely. So if you grant me those things, which are very controversial, right? Because if you get me those things, then you will get that every Bohmian particles depends partially on every other Bohmian particles, and this will be coherentism. But of course, I mean, both the bridge principles, right? That from dependence between qualities of me and Paul to dependence upon one respect of me and Paul, and dependence from one respect to just plain dependence of me and Paul, both, as a matter of fact, are controversial. And so yes, I don't know what to say about those.
Yeah, thank you very much. That clarifies a lot. So I think more about if and how it fits with Bohmian mechanics, but I get the idea, and the first objection I just take back. You just clarified. You mean? Okay,
well,
thank you.
It's nice to see you.
Thanks.
Paul, if you have a very good...
But it's just, I mean, it was just something that Claudio just said, in fact, which reminded me of something which I thought about in the talk, which was, do you see the coherentism as being somehow dependent on non-locality, entanglement non-locality? Because, well, I'll leave it there. I mean, to expand a bit further, some people who support many worlds would say that there's no entanglement, no non-locality, there's no EPR, but EPR Belge, I'm looking for the name. There's no EPR Belge non-locality for many worlds. So, so is there a connection with non-locality? Is somehow non-locality necessary part of your view of what coherentism involves?
So is the thought that if you are a many world guy, you don't think that the probabilities for the joint state fail to factorize? If they do factorize, if they do, then there is no ontological question.
I think it's simply that if you, I mean, the problem is there are various views of many worlds. But if you take the sort of view of many worlds which Lev takes, and which I take as well, but in a slightly different way, then when you get Alice, Bob, Charlie sort of setups, what happens on measurement is fission. I mean, there's no Alice splits, Bob splits, Charlie splits. You can't get the Bell inequality argument work. It doesn't work if you accept that picture. I mean, there are alternative pictures to many worlds, which maybe that doesn't apply. But so I would completely agree with Lev, for instance, that there's no. The implication is that for many worlds, there's no spooky action at a distance, right? There's not non-locality in that sense.
But basically, I think, Claudio, we agree on the fact that, you know, your classical mechanics has a very simple ontology. I mean, very intuitive ontology. It's not mysterious, and it is basically Humean in the sense that you have local monadic properties, and if you put different systems together, they don't surprise you. They just sum up. And if I understand correctly, many worlds, then you have a multiplication of classical stories, right? In that case, there is no point in being specifically a coherentist, specifically about quantum mechanics. Then, as we try to mention, it is not just about quantum mechanics, but today it was. So I would agree with you. It really depends on your interpretation. And Claudio and I are really aware of this. It is about time we start talking about specific interpretations. We know that. And I think you got a point.
Okay.
Yeah, I just agree. So, I mean, so we made coherent. So in the paper, for example, we use coherentism to actually give you non-causal, let's say, explanation of the Bell type scenarios. And of course, if you're many world theories, you know, you will not need the story. So you will lose some, let's say, initial appeal of coherentism. As a matter of fact, I agree with you. It's true.
Okay. Yeah.
Okay, we don't have much time, and we still have 4 questions. I'm not sure we can have all of them, but so next one is Mauro Dorato. Mauro, you are muted.
You're muted.
Still muted. Wait, I'm gonna ask you to unmute.
Activate my audio. Can you hear me now?
Now it works.
Yeah.
You can go
Great.
on.
So first, thanks to Christian for having put up this series of workshops. I think it's very important that we guys can talk to each other. And then some congratulations to Matteo and Claudio. I reread our paper, and they're really masters in combining metaphysics and physics. They know a lot about the two subjects, but now the but part. The but part, I don't know what, are you ready? Because I don't know what dependent means, dependence. You talk about dependence, I don't know what it means in science. I have 3 possible readings. One way to cash it out is probabilistic correlation, which obviously is fundamental, and quantum correlation. Notice that probabilistic correlation is symmetric and irreflexive, like your notion of partial dependence. But correlations are not causes, and this is well known in probability. And we look for causes often, and causes are time asymmetric. Now, you have this dilemma. Either there are no causes for entanglement, and then we have to say that correlations are fundamental in the same sense that free fall or inertia are, or if there are causes, then we must introduce time. So there's a second sense in which you can talk about dependence. It can be a relation between physical magnitudes, for instance. And typically this is established by a physical law. And I think Matteo did well in mentioning that the notion of substance has been replaced by the notion of law. And then this is the line that comes from comes from Cassirer. But now, this is my point. There are laws of coexistence and laws of evolution. And it seems to me you just talk about laws of coexistence, while in science in general, it's the latter kind of laws that are more important. But think about the law of coexistence as the Boyle law. I mean, that relates pressure and volume and temperature, as you know. But laws of evolutions are much more important. And because the world evolves, so you have galaxies and then stars and then planets and then life. So it seems to me that if you just concentrate on the problem of quantum correlation, which of course you can do, you forget the possibility of explaining them in a temporal way. So you're assuming that they are fundamental, but if they are fundamental, then you don't need any explanation. So probably I talk too much, but you're leaving out time, it seems to me, in this discussion.
Claudio.
Well, yeah, tell me.
I was actually, so I was writing down because I think it's important. So two things, I think so first of all, we might very well be an expert in the conjunction without being expert in the conjunct of metaphysics and physics. This is a weird thing in which, but so I mean, for more serious things. So I think you're completely right. So at least that's what I was looking at. So we weren't looking for causes, and we clearly weren't looking for, temporal. So we just set it aside. And as you pointed out, I mean, that is just a very tiny part, and maybe the less important part of physics and physical explanations. So we should clearly, so whether there are diachronic relations of dependence, I honestly don't know. Like, it might be very well investigated. So in that case, given Bohmian mechanics, in which the velocity, which, I mean, it's not, but it's usually taken to be like not a, let's say, an instantaneous property, right? It depends on the position of all the other particles. Might be one way to look at. But I will just simply grant that we just didn't look for this, at least as of now.
Of course, but why not using the notion of probabilistic correlation, which we know what it means, rather than relying on this notion of dependence? And I don't know what that means, especially scientists don't know what it means, unless you talk about laws.
With that, so, I mean, I can say two things here. Like, so first of all, it seems to us, so for example, so there are two questions, right? I mean, it seems to me, one is unintelligibility, right? I don't know what they are, and why do you bring it? And the second is, even if you make me understand what they're bringing more to the picture, right? So for the unintelligibility part, I don't know what they are. I'm just gonna say, so for example, clearly, for example, in the last part of the talk, we just took it as a primitive, and I just give you a formal, a formal
of course.
It's fine. So these, I would say, we could be subject to the objection. But now, in the first part, like, we talk a very specific, dependence relation, and we just define that in terms of model operators, entailment and existence, and quantifications. Now, it seems to me that in that case, anyone that understands that should understand what I say. Like, because it's just, so the most straightforward definition, for example, the ones that usually no one uses anymore, like the model notion of dependence is just X depends on Y, if and only if necessarily existence of X entails the existence of Y. Now, I just defined that using existence, just first order logic and model operators. Now, I can even grant you that you can read the model operators as nomological possibility. So I think that just by doing this, I think I shielded myself from the fact, I mean, if you insist that you don't understand, then I'm just gonna say, well then, I mean, I don't know what to do because I just gave you a definition of that.
No, it's not that I don't understand, but scientists would have a hard time to understand it.
No,
I don't think that's a worry. I mean, we're doing philosophy here. Scientists don't need to understand.
I worry about that.
No, I don't think, we discussed this many times.
It's time that physicists get a course on first order logic.
Yeah, I think so.
It's just time that physicists do model logic. That's what we.
I think it would be too ambitious on our part to convince physicists that they should use this concept. They should use them as long as they want to do, if they want to, philosophy of what they're doing. But that's a different thing. I mean, it's not like if you do philosophy of food, you want to convince cooks of certain concepts. It's a different level.
No, but look, probability.
Mauro, can I ask you to have like a very last quick remark?
Yeah, sorry.
No, sorry, you. I'm really enjoying this, but we are running super late.
I can talk to Matteo. Just probability is also a model notion. So anyway, I'll stop.
Yeah, again, sorry for interrupting you.
No. I just.
Can I just say one? I think one thing which is important. Which is apart from probabilities, I think you're right, and then in a certain respect. But I might want to disagree a little bit about what, just a bit, because
thank you for asking.
Just about when you claim, for example, if they are fundamental, right? When you say one part of the objection was if they're fundamental, you don't need to explain them. Now I think that that's wrong, just because that actually. Meaning the following: this goes through if and only if you think of fundamental as independence. And our point is exactly that. I think that coherentism gives you a picture in which fundamentality is not independence. Therefore, the fundamental items can be explained. As a matter of fact, what the fundamental items should do, they should not be unexplained. They should explain everything else.
Okay.
So that I think where we probably part ways a little bit. And it's an interesting question whether physicists, are more attracted to the view according to which the fundamental level should explain everything else, or whether the fundamental level should be the unexplained one. I don't have any clue here, like whether the physicists are more attracted. We have a bunch of those here. I honestly don't know. It's just I honestly don't know.
I don't know if Matteo, you have a last remark to make on this.
Actually, I want to say that I think Mauro got exactly the point right. We started off, in a sense, we started off by realizing that a causal explanation of Bell's inequalities, the violation of Bell's inequalities, is not forthcoming. So then you have two options. Either you take them as fundamental in the sense that you cannot explain them. And this seems to be your position. And this assumes that whenever you use concepts which are not actively used by scientists, they are not informative. And I agree with you, you can do that. So the natural thing to do in that sense, you just take the non-factorizability of probabilities as a fact. And I agree with you, you can do that. The other thing that we do, of course, assumes that we are talking to people that agree that grounding talk, dependence talk is informative. It's a big if. We are just saying, look, we cannot use probabilities. That's the fact that we want to explain. And you say, well, it cannot be explained in terms of anything more fundamental, in the sense of physically fundamental, scientifically fundamental. We agree with you. And that's why we are doing metaphysics of science. The big if remains. I mean, if people don't buy into this grounding talk, the things we've been saying for 2 hours, obviously they will not cut any ice. And I agree with you. I mean, I know that you don't get convinced because you don't see the point. And there's not much I can do. I'm just repeating the things. I mean, as a philosopher, you should say, well, I don't care about the theories of truth because I know when a proposition is true. But as a philosopher, you will say, no, the fact that X is P grounds the truth of the proposition X is P. What I'm trying to say is that whenever you give philosophical explanation, typically they don't use scientific concepts.
I agree.
Yeah, that's our starting point.
Thank you all guys. That was a very nice exchange. And okay, so I have to say sorry to myself, Aurelian and Alberto, who were on the list. But I have to go, I really have to go to get the vaccine, which is a good news, but which means I have to really finish the meeting today. Sorry, well, I was joking on myself, but sorry to Aurelian and Alberto. I couldn't allow you to ask a question.
But you can write.
Sorry?
Please write, I mean, you can write us, right? We will be happy to actually discuss this thing.
Yeah.
You can maybe send it. Well, you have the emails in the mailing list. So,
Christian, I can try to chair the discussion.
I mean, I don't want to be unfair to the speakers. I don't want to force it, because if I leave you the chairing, then but it's up to you.
If people want and the speakers want, otherwise I'll have to
I don't
ask
mind.
your apologies for having.
I would be happy to. Okay, let me first stop the recording because it's on my computer. So I'll do this.